All right, let's do a gravitational field one, right? With gravitational fields, remember the gravitational fields are just toward the mass, right? So the gravitational field due to mass B is just toward B, right? So G sub B is that way, and the gravitational field of mass A is toward A, right? Okay. And so what we're going to do is we are going to, I guess, just find those things, right? Let's find the magnitudes, right? So the gravitational field of A is 6.67 E minus 11 times 9.4 E12 divided by, and then this is R squared. So let's see, A is 2 over and 1, 2, 3, 4 down. So it's the square root of 2 squared plus 4 squared. But that whole thing is squared, right? Because our formula here is gm over r squared. And that actually is in the data packet, which is so good. Okay, so let's see. Do we have it right? So A is that, yes. Oh, whoops. No, A. Okay, we're doing A. Yes. 9.4 and then 2 squared and 4 squared. Okay, so here we go. 6.67 E minus 11 times 9.4 E12 divided by the square root. Whoops, I not got a square root. Let's delete. Parenthesis. Okay, I just go parenthesis 2 squared plus 4 squared. So the square root really goes away. I get 31.349. And then let's find the gravitational field of B. That's going to be 6.67 E minus 11. And then B is 1.8 E12, right? And then the distance to B is 2 squared, 2 over 2 down, right? So 2 squared plus 2 squared, right? Now really this is the square root of 2 squared plus 2 squared squared, right? It's really the same. These are the same thing, right? So now I'm going to go this guy and then just change this, right? 2 and then this is 1.8. But everything else is the same. Yes. All right, here we go. All right. All right, I think we're ready to, we're cooking with gas. This is 15.0075. And these are, of course, newtons per kilogram. Newtons of force per kilogram, right? Or meters per second squared is really what they are too, right? Okay, so now, now we got to find the angle. All right, so here we go. We've got G, A, G, B, look how straight a line I can draw. Somebody was saying, you say that every time. See, I think it's really clever. Okay, so magnitude. Okay, so A is this guy, 31.349. And B really is this guy here, right? I'm just double checking. All right, here we go. Okay, now let's see the angle. Okay, so B is the easy one. Let's see, this is, I guess this is 180 degrees. And it's 45 degrees past 180, so it's 225. Is that right? This angle here is 180 plus 45 is 225. I do believe that's correct. Okay. But then this guy here, okay, so let's see. Here, let's do all right, and I wish I could do a diagonal line, right? So this angle here is, let's find that guy here. That's going to be inverse tan of, let's see, 1, 2, 3 fourths. Inverse tan of 2 fourths. So second tan of 0.5 That's 26.565. Now notice that this is 270 degrees from P, right? So 0, 90, 180, 270, and it's that much more than 270. So I'm going to say that it's 296.6 is close enough, right? 296.6, so plus 270. 296.565 is what it is really, right? And now let's find the x component and the y component. Okay, let me see. Does that make sense? That's the A, and this is this, and that's A, and this is... I'm just double checking because I do stupid things like I'll switch the angle. I did that on one of these stupid videos. I did the whole thing and I was like, oh, it's wrong. All right, here we go. Okay, so 31.349 times cos of that 296 thing. This should still be a positive number. 14.02. 14, yeah, 14.02. So I did this times the cos of this. And now, I'm so lazy, I'm going to do that times the sine of that. That should be much more. Okay, negative. Ooh, it's good. So it's negative. That component's negative. This guy's positive. So negative 28.04. These are newtons per kilogram, right? That makes sense. Okay. So now let's do this guy, the 15. Let's find that 15 guy. There it is. Cos 225. Negative 10.61. Is that possible? I guess so. This guy should be also negative 10.61, but let's just try it. Sine negative 10.61. Because it's in this quadrant, right? It's in the third quadrant, right? All right, now we're ready to go. Let's add the... Let's add these guys, right? 14.02 minus that guy plus this guy. 3.408. That's a 4. All right, and then this guy is negative 38.65. All right, so let's draw a picture of this guy, right? It's going to be over a little bit, down a whole lot. Okay, so let's start here. Over a little bit, down a whole lot. So this is 38.65. This is 3.408. And then there we go. How is it? It's 85 degrees with the x-axis. Okay, so they're finding that angle there, right? So that angle is going to be theta is tan minus 1 of 38.65 over 3.408. Let's do it. Okay. Second tan of this guy divided by this guy. 84.96 degrees. Right, which is basically 85 degrees. There we go. And then this magnitude here, so that's 85 degrees. And then this magnitude is the square root of 3.408 squared plus 38 0.65 squared. I'm going to use unrounded values here because, oops, I better put it in parentheses because TI calculators are special. All right, that squared plus that squared. I get 38.8. This is 38.7. This is 38.8. So when you have a triangle, of course, with a really small side, the hypotenuse is essentially the length of the longer side. And this is newtons per kilogram. So down and right, barely to the right, at 85 degrees with the x-axis. So there's the x-axis. There it is. Yay! Little dogs. There we go. All right.